Water can be represented either as a structural formula, which says that I have a hydrogen bonded to an oxygen, bonded to another hydrogen, or as a molecular formula, H2O. From the molecular formula, we can determine the molecular mass. The molecular mass is the mass of one molecule of a compound in atomic mass units, or AMU. Now, the molecular mass isn't that convenient to use. Usually what we want to use is the molar mass. The molar mass is the mass of 1 mole of a compound, and this will be in grams per mole. It's also known as the molecular weight. Now, the molecular mass and the molar mass are the same thing, same number, just with different units. Let's look at an example. So I have hydrogen, which has an atomic mass of 1.008, and I have oxygen, which is 16.00. Now, the numbers you have on different periodic tables will vary slightly, but that really isn't that important when we're doing calculations. So if I want to know the molecular mass for H2O, I have 2 hydrogens and 1 oxygen. So it'll be 2 times the 1.008 plus 16 for the oxygen. And this will tell me that 1 molecule of H2O is 18.016 AMU, or 1 mole of H2O is 18.016 grams. And so this is our molar mass, 18.016 grams per mole. Now, let's go ahead and let's look at another problem. So let's determine the molecular mass of ethane. We have the structural formula there on top, and we can see that we have 2 carbons and 1, 2, 3, 4, 5, 6 hydrogens. So it's C2H6. So if I want to figure out what the molecular mass of the ethane is, I can take 2 times the molecular mass, or the atomic mass of carbon, 12.01, plus 6 times the molecular mass of my hydrogen. And this is going to go ahead and this will give me the atomic or the molecular mass for my ethane, 30.068 grams per mole. So I look at the molecular formula, I use the subscripts to figure out how much of each element I have, and then I use the atomic masses, and that gives me my molecular mass. Let's look at a slightly tougher problem. Let's look at aluminum sulfate. Aluminum sulfate is an ionic compound with the formula Al2SO4 3. Notice the SO4, the sulfate, that is a polyatomic ion, and that's why we have to have it in parentheses. So this means that my molecular mass is 2 times the molecular mass of my aluminum. I have 3 sulfurs, and I actually end up with 12 oxygens, right? Because I have 4 times 3. So I can take 2 times 26.98, that's for the aluminum, plus 3 times 32.06, that's for the sulfur, and then 12 times the 16.00 for the oxygen. And so when I do this, I get 342.14 grams per mole.